These are the examples for Lesson 4 in Module 2 for Grade 7. In this lesson, we'll be talking about adding our numbers, our integers, more efficiently without using a number line. But we're going to be using the number line to support our conclusions we come to. In example 1, we're going to represent the sum of 3 plus 5. First, we're going to do it using arrows on the number line. Here's our first arrow representing 3, and our second arrow representing 5. The first arrow that represents 3 is 3 units long, and it points to the right because it's positive. The arrow representing 5 is 5 units long, and it also points to the right because it is also positive. The sum of these two numbers is 8. We can see that this would be an arrow from 0 to 8 units long and to the right. If we want to know what the relationship between the arrow representing the number on the number line and the absolute value of the number is, we can see that they are the same. The arrow's length is the same as the absolute value of 8. Question 8 asks, do we think that adding two positive numbers will always give you a greater positive number? And why? Well, every time we add a positive number, we're going further to the right, and all of our positive numbers are to the right of 0. So yes, adding two positive numbers will always give you a greater positive number because the arrows all point to the right. Let's take a look at another example, but this time we're going to add two negative numbers. We're going to represent the sum of -3 and -5 using arrows that represent -3 and -5 on the number line. Here's our arrow for -3, and here's our arrow for -5. The arrow that represents -3 is 3 units long, and it points to the left because -3 is negative. The arrow that represents -5 is 5 units long and also points to the left because -5 is a negative number. The sum of these two numbers is -8. They end at the number -8. If we were to draw an arrow that represents this sum, it would be 8 units long and it would point to the left because -8 is negative. Question 7 asks, do you think that adding two negative numbers will always give you a smaller negative number? And why? When we add negative numbers, we start at 0 and we move to the left, and we keep moving to the left. The numbers to the left of 0 are all negative, and the further to the left you go, the smaller those numbers become. So yes, adding two negative numbers will always give you a smaller negative number because the arrows all point to the left. Part C asks, what do both examples have in common? In the example where we were adding positive numbers, they all went to the right, and when we were adding negative numbers, they all went to the left. Both examples are adding two numbers with the same sign. The sum of each example also has the same sign as the numbers we added. When we added two positive numbers, we got a positive answer. When we added two negative numbers, we got a negative answer. Let's take a look at an example where we're adding two numbers with different signs. We're going to represent 5 plus -3 using arrows on the number line. Our first arrow starts at 0 and represents 5. Our second arrow represents -3 and starts at 5 but goes to the left. The first arrow is 5 units long and it points to the right because 5 is positive. The second arrow is 3 units long and it points to the left because -3 is negative. Question number 5 asks, which arrow is longer? Well, when we have them lined up like this, we can see that the first arrow that represents 5 is longer than the arrow that represents -3. And question 6 asks, what is the sum? Well, you can see that this arrow ends at 2. And then if we were to represent the sum using an arrow, the arrow would be 2 units long, starting at 0, and it would point to the right. You can see this arrow pointing to the right is the same direction as our 5 that points to the right. The arrow represented would be 2 units long and is pointing to the right, right there. If we do this again, but this time with an example where our negative number has the longer arrow, we can show 4 to the right and then -7 going to the left. We end up at -3. We would represent this with an arrow that is 3 units long going to the left. If we wanted to talk about how we got this, we can say that we subtracted the length of -7 and the length of +4. The absolute value of -7 is 7, that's the length of the arrow, minus 4 gives us 3, the length of our sum. If we wanted to know the relationship between the direction of the arrow representing the sum and the direction of the arrows representing the two add-ins, or the two numbers we added, if we looked at -7 and +4, -7 is pointing to the left, +4 is pointing to the right. Our answer is pointing to the left. It's a negative number. So the direction of the arrow representing 4 plus -7 is the same direction as the direction of our longer arrow, -7. If we were to write a rule to give us the length and direction of an arrow representing the sum of two values that have opposite signs, we could say that the length of the arrow is the difference between the absolute values of the two add-ins. That means subtract the absolute values. The direction of the arrow is the same as the direction of the longest arrow. Let's apply this rule to an example where we're not using integers, we're using rational numbers. In this case, fractions. We're going to find the sum of 6 plus -2 1/4. We're going to follow the same rules of addition for integers. First, we're going to find the absolute values of the numbers. The absolute value of 6 is 6. The absolute value of -2 1/4 is 2 1/4. Now we're going to subtract those absolute values. We can break it up into bits and pieces, where 6 plus -2 gives us 4, and then 4 plus -1/4 gives us 3 3/4. Sometimes looking at that on a number line with fractions is a little easier. I have a number line down here which is broken up into fourths. Each of the smaller marks represents 1/4. If I want to represent 6 on my number line, this is the arrow I would use. If I want to represent subtracting 2 1/4, I start at 6 and first I subtract 2, then I subtract 1/4. And you can see that I end up right here at less than 4, 1/4 less than 4 in fact. If I wanted to draw an arrow that represents this sum, I would draw an arrow that is 3 units long and then another 3/4 of a units long. So this is 3 3/4. So since 6 has the greater absolute value and is in positive, my answer is also going to be positive. The length of the arrow for 6 is longer than the length of the arrow for 2 1/4. And this is what my answer would be. All right. Make sure you have all of your notes written down. We'll go over some of the problem sets in class, and we'll see you later.